In lesson 1.8, a couple of different learning goals. Yesterday's learning goal was I can write and solve proportions. What's a proportion again? What is a proportion? Alexis?
A statement that two ratios are equal.
Yeah, a statement that two ratios are equal. So yesterday that's what we were working with, but we're still working with ratios. We work with ratios really throughout this lesson. But today's learning goal says I can write and use rates. So a rate is a ratio, but it's a special type of ratio. We should be able to fill in this blank right away because we already defined the word rate. A rate is a what? A ratio of two quantities with what? What has to be true for it to be, if the rate is going to be considered, or excuse me, the ratio is going to be considered a rate, what has to be true about those two numbers you are comparing? They have to have, Alexis?
Different units.
Different units. They have to be different units. So if you were going to compare two things, they have to be different units. If you're going to compare hours to hours, you could divide that out and it would still just be hours. When we have a rate, we have two units involved in our labels, okay? And they are usually written as, typically how are they written? Unit rates. And in a unit rate, the second quantity is what? How many units? One unit, one. So when we write it as a unit rate, it's per 1 unit. There's only one in our second comparison. In the comparison of the two numbers, our second number is a 1 of something, okay? Such as, here are some examples. How many quarts are there for every 1 gallon? 4. How many minutes are there for every 1 hour? 60. And how many miles are there per 1 gallon? You're shaking your head. It depends, doesn't it? Depends on what? Mileage, what you're driving, right? Your car might get better gas mileage than mine does. You drive a hot rod truck, it's probably going to get less gas mileage than mine does. It depends on what you're driving, right? So we're going to put an X here. But it's still a unit rate, though, because it's comparing it to what? 1 unit. Yeah, it's comparing it to 1 unit. So a typical way we would see this written is we would not see the 1 in front of the gallons. We know that it means per 1 gallon, 4 quarts per gallon. The next one could be written 60 minutes per hour without putting the 1 there. The next one could be written X miles per gallon without putting the 1 there. When there's not a number in front of our denominator's label, unit of measure, we know it means per 1. It's a unit rate. Okay, and we're going to typically simplify our rates so that they are a unit rate, so that we can talk about them that way. So to find a unit rate, set up a ratio in proper order and simplify. What do I mean by proper order? What do you think? Anybody here have a job? Yeah? You're paid by the hour, or are you willing to share? What, Landon? By the hour? Okay. So if you get paid by the hour, do you typically do this? You say, I work at such and such, and I get half an hour for $4. Is that what you say? I work a half an hour for $4? No. How do you say it? I work $8 per. I get paid $8 per hour. We talk about the dollars per hour, not the hours per dollar, right? We don't talk about how many hours we have to work to earn $1. We talk about how many dollars we get for every hour that we work. So order matters to make sense. So when we're setting them up, when we set up our ratios to get our unit rate, that's what we're going to do. We're going to set it up as a ratio. You do get to use your calculators today, so go ahead and get them out. If 12 gallons of gasoline were used for a distance of 222 miles, what is the number of miles per gallon? This is telling us right here the order we should set our ratio up in, isn't it? What should be upstairs? The 222, and we're going to use labels. MI is the abbreviation for miles. Can't use M. What does M stand for?
Meters.
Meters. And miles per gallon, how many gallons of gasoline? They used 12 gallons. I think you can just get away with just a G for gallons now. I grew up using GAL, so I still do. Okay. This really means that here's what we're going to put into our calculator. I'm not saying you have to write this every time, but let's at least write it this time to show how are we going to get our answer. We're going to put 222 into our calculator, divided by the denominator 12, and give our answer. It will now be as a unit rate, because we're really saying 12 goes into itself once, and how many times does 12 go into 222? How many? 18.5? Okay. So it goes in there 18.5 times, so it's 18.5 what? Miles per gallon. So we could write it like this, or what would be another way we could write that label? Anybody know? What's another way you might see it? MPG, yeah, or MPG. That's another way you might possibly see that same thing. So you get to use your calculators, but you need to show me the ratio setup, okay? You need to show me the ratio with the labels in it. We're gonna get in the habit of putting labels in here because it's gonna help us, especially when we have to do those conversion factor problems that are coming up here shortly. So Corey earns $52.50 in 7 hours. Find the unit rate in dollars per hour. What needs to go? Just tell me what label needs to go upstairs. Dollars, because it says dollars per hour, and the hours go behind, don't they? So we're really going to put the $52.50 upstairs and the 7 down, and we're going to divide it out and see what we get. What'd you get, Zach? Okay, this guy is making $7.50 an hour. All right. We could do per hour like this, or we could just write, since the dollar sign is in front, we can leave this fraction bar out of there. We could also write it just like this because the labels are already separated from each other. By the way, the dollar signs never go behind the number. It's dollar signs always go in front, don't they? Okay. Go ahead and do that last one. Figure out the rate that car is traveling. Show your setup first. What is going to go into your calculators? Sophia?
Oh, I have a question.
Okay. Okay, somebody give me the ratio they set up on their paper. This is exactly how it looks on your paper, Alexis.
294 miles over 4 hours.
I think you meant 92, right?
Yeah.
Yeah, okay. Like that? Okay, and what does that equal?
73 miles per hour.
73 miles per hour. Do we agree with her? Okay, 73 miles driven every hour, with that having been what they traveled, 292 miles in 4 hours. The average their speed was 73 miles per hour. So they kind of seem like no-brainers, but you know what? We sometimes, here's what I see students do. I see students take the information given in a problem, and the first number that they give, they put it upstairs in the ratio. The second number that they give in the problem, they put it downstairs, and they call it good. And then sometimes, here's what also magically happens. Like, let's say you had a 2 upstairs and 2 of something, $2 and maybe a 4 downstairs, and let's say that's, minutes, and you magically got for an answer $2 per minute. with a 2 upstairs and 4 downstairs. Is that gonna happen? 2 over 4 is not 2, it's what? 1.5. That would be a 50 center, not a $2. So we have to make sure that our ratios also make sense as we set them up. Okay, let's go to the back side, where we're going to use dimensional analysis, which means you're really just changing it to a, okay, what's our book definition for this one, or a definition that you wrote down in your SQ3Rs? What's the definition that you wrote down in your SQ3Rs? Connor, what do you have?
Process that uses rates to convert measurements from one unit to another.
Yeah, process that uses rates, so we're going to use rates. Rates have to have a numerator and a denominator, a ratio, to convert from one type of unit to another type of unit. So here's what you guys typically have been doing in the past. Okay, I'm going to read your minds. I'm going to read your past. Okay? When you have to convert inches to feet, you probably have just said, well, what do I have to do to convert inches to feet? What do? If I have, I don't know, 96 inches, and I want to convert it to feet, what would you do in this case, Matt? What would you do? You would divide by 12, yeah. You're like, I know I need to divide by 12. Well, we don't always really know what we need to do, so we're going to do it as conversion factors. We're going to set up rates, and we're going to, so they're going to be fractions, and we're going to use labels in them so that we can make sure that we're, really doing the right thing, because we're going to be doing more than one thing sometimes. We're not just going to be multiplying one time or dividing one time. We're going to have to make more than that decision, and it works easier with conversion factors. Plus, Mrs. Claybo expects you to know how to use conversion factors in science class. So, first thing we're going to do is we're going to say, here's the information that they gave us. They said a cyclist travels 56 miles in 4 hours. Would it make more sense to put the miles upstairs or the hours upstairs? Miles per hour or hours per mile? Miles? Okay. So we're going to start with that ratio, 56 miles over 4 hours. And you know what? We're not even going to divide that out right now, make it a unit rate. We're just going to convert it to what they want us to convert it to. They want us to convert it into feet per second, don't they? So we need the miles to be changed to feet and the hours to be changed to seconds. You want to go with the time first or the distance first?
At this time, please dismiss the band students.
You want to work with the distance first or the time first? You get to make the call. Because we're going to just do one or the other first. Distance, did I hear? Okay, let's do distance. We're going to multiply by a conversion factor, and we need the miles to go away. So where should the miles be? This is the first decision I always make. Where should the miles be in my conversion factor if I want them to cancel away? On the bottom. If we're going to cancel, we have to have one up and one down when we're multiplying. Okay? So now we're going to convert miles to, can we go directly from miles to feet? Is there a conversion factor for that? Anybody happen to know how many miles are in a foot or how many feet are in a mile?
5,280.
Oh, and those are feet? Okay, so we can use a conversion factor with feet in it. We can go directly to feet. In other words, from miles to feet. So you said 5,280 feet. There's some conversion factors you're going to want to get memorized. There's 5,280 feet in every 1 mile. So we're going to cross out our miles because that's the goal. We need some labels to eliminate. We want the miles to eliminate and become feet. So now let's do our multiplying cross before. Let's just do this one step is all. What's 56 times 5,280? Okay, 295,680. Did I hear that right? Or right, that what we get? And we look at and see what labels left upstairs. Well, there's feet left upstairs right now, so those are feet per what? 4 times 1 is 4, and those are hours. Okay. Now, chances are 4 goes into this, and we could simplify this if we wanted to, or we could just keep going. We have feet per hour right now. Are we done? Feet per hour. No, we want feet per second. So we're gonna bring that down here and we're gonna do another conversion factor. I hope I can follow your work when I have to look at it. I hope it isn't, multiplying here and dividing there and it's all over the place and I'll be like, I can't follow that, I'm not even gonna try. So we don't want to convert the distance anymore. We're done with that, right? So now we want to convert the hours. We want those to go away. So now we're going to say, I'm going to put hours upstairs because they're downstairs in the other factor here. Well, there's another element of time between hours and seconds. What is it? Minutes. So we're going to start by converting to minutes first. So let's finish out our conversion factor. What should we put? 1 hour, 60 minutes. Notice the per one is upstairs, but that doesn't matter in a conversion factor. In a conversion factor, it can be either up or down. Why we want it to be this way is we want those hours to cancel out. If something doesn't cancel out, we don't have a good setup. Well, we're taking that 295,680 times 1, so that's going to stay that. And those are still feet. And now we're going to take 4 times 60 downstairs, and that is 240. And those are what? Minutes. Okay, are we ready to change this into a unit rate? Do we want feet per minute? No, we're still not ready, are we? Okay, so here we go, we'll do it again. 295,680 feet over 240 minutes. And we're going to have to multiply by another conversion factor because we still don't have our seconds. So we need the minutes to go away. So we're going to start like this. We're going to say minutes, you got to go away, so you got to be upstairs. Minutes up, seconds down. What are we going to put? 1 over 60. 1 minute has 60 seconds in it. And now we will have our minutes are going to cancel away. We have 295,680 feet over whatever 240 times 60 is. What is it? No, I think it's more than that. I think it's 14,000 something. 14,400, yeah, it's 14,000. 60 times 60 would be 3,600, but we have 240, so 14,400, and those are seconds. Well, look at there, we finally have feet per, feet over seconds, don't we? We have so many feet per so many seconds, but we want it as a unit rate. Now you're going to divide it out on your calculator. So what is, and what does it say? Round your answer to the nearest 10. So what is 295,680 divided by 14,400 rounded to the nearest 10? Come on, help me out. I don't know what to tell you. Alexis?
20.5
Okay. Okay, and we have to use our approximately equal to sign because we're rounding. 20.5, do you guys agree with her? 20.5, approximately 20.5 feet per, well that's a T, not an F, second. I think we could also, in this one, you probably would get away with FPS. I think they do that too, FPS, but, okay. So we're just going to do that one conversion problem, but this is how I want you to do them. I want you to use rates. The ratios set up as rates are going to have a different unit up and a different unit down. We need things to cancel away. Sometimes we don't have to change one of them though. You know what? If they had asked us, we were given this in miles per hour. If they had asked us for it in miles per second, would we have had to mess with the distance conversion factor? No, the miles are going to stay miles. We don't have to change those. Then we would only have to worry about changing the time. Anybody have questions? Hey, here's just a practice problem from yesterday. Set it up. You already know how to solve proportion. Set it up, and then we could talk about whether you have a good setup or not. Remember, cross products is what we're going to do. So we have somebody share theirs with me. Alexis, thanks for showing up today.
N plus 3 in parentheses times 2 equals 5 times n in parentheses. Wait, no, 5 times n minus 1 in parentheses.
Okay. Okay. So that's one way we could write it. Because you can put this, we can do backwards distributed property, right? The other way is, or we could have that 2 out front. You don't even need to show the multiplication dot, do you? Can we do that? This is 2 times n plus 3. And this is 5 times n minus 1. We could do that. Or the 5 times the n minus 1 could be over on the left side, and the 2 times the n plus 3 could be on the right side. Go ahead and solve that now for n. You're going to have to use your distributive property skills. You're going to have to use the fact that you're going to end up with variables on both sides. That's a less than 1.5 skill. Anybody starting to feel like something went wrong? You're feeling okay? Whenever I get a number over here that isn't a multiple of the number on the other side, I'm like, oh, I must have made a mistake. But not necessarily. You guys get 11 also? Yeah? Okay. So, what's our final answer for this one then? What would be acceptable answers in this classroom? Alexis? What's more?
N equals 11 over 3.
Okay, we could leave it as 11/3. Or is there another choice? How about this? Go ahead. 3 2/3. N equals 3 2/3. That would be another way we might see it in an answer bank. How about its decimal thing? What's 2/3 as a decimal? 1/3 is 0.33333. 2/3 is 0.66666. So, is that kind of decimals I like you to write? No, is that what I call a nice decimal? No, it doesn't terminate. So when they're repeating decimals, we don't want to give it its decimal name. We're going to leave it alone. We're going to say one of these 2 choices is fine, but not its decimal name. Okay? Any questions? It is homework time then.